When you graph a system of equations, there are three different possibilities for answers that you could have. One of them is where our lines intersect, where they meet at a point. And we say our solution is what? It would be that point where they meet or intersect, whatever that is. It'll be an x comma y, some ordered pair. Another option is what? How else could our graphs look? They can be parallel. Good. If our graphs are parallel and they never intersect, what do we say our solution is?
No solution.
No solution. We would either use our symbol of no solution or we would write out the words no solution. We have a third option as well. If we graph a line, and then let's say we were going to graph our second line and it happened to be the exact same equation. So we have two lines, one on top of the other. So really we're graphing the same equation twice, right? And I want to know, what are my solutions? Well, if your solutions are where your graphs intersect, where do my graphs intersect here? The whole thing. They're intersecting along every single point that's on this graph. You're on the right track. We wouldn't see orbital numbers because we're not necessarily talking about the types of numbers or types of solutions we have. Instead, we're talking about all the possible solutions. Well, in this case, we would say that we have infinite solutions. A couple of ways you could write this. You could write the infinity symbol and say infinite solutions. Or you could write out the words infinite solutions.
Are you going to some of the board for today?
I can. But these are your three options. When you're solving, when you're graphing systems of equations, there are three possibilities that you could have. And these are the three options. Here, how many solutions do we have? One. We have one solution. Here in this example, how many do we have? No solutions. And then down here we have infinite solutions. So there's three different options. Your graphs could do three different things. And if you think about it, if you have two lines, they can either intersect once, never, or they can intersect everywhere. Can we make them intersect twice? Can we take two straight lines and make them intersect in two places? No, we can't. We can make them intersect once, never, or we can make them intersect infinite number of times. And that's it. So this right here, the infinite solutions, is our new concept today. Thinking of that. So if you graph an equation and you find out the second equation is exactly the same, then you would have infinite solutions.